All right, welcome everyone. For those of you just arriving, please come up to the front. You're hurting my feelings by all trying to run to the back corner. Okay, so before we get started with the content, just a quick show of hands. Raise your hand if your friends and family consider your sense of fun to be questionable. Awesome. And so for those of you who didn't raise your hand, I'd just like to remind you that of all the things you could be doing under the Las Vegas sun, including playing with Visible, you have chosen to attend a session that has in the title a terrible pun, a Star Wars reference, and data geeks. Come on! All right, so second question for you guys. Who here has used LOD expressions before? Good, that's the answer I was hoping for. So for those of you who are new to LOD expressions, just want to give you fair warning that this is not going to be the nice, easy introduction to what are LODs at all. This is the, we have a Ferrari, let's take this thing and make it fly. All right, so what you can expect to get out of the session today is if you've been working with Tableau for a long time, you'll have realized by now that probably 95% of the things you want to do are very easy to find in Google. And the other 5% of things, you can waste days trying to come up with search terms that people use to describe those scenarios. So I'm really hoping that you'll leave this session needing to Google a lot less and actually being the gurus on the forum who are creating the terms that are yet to be determined for those use cases. And so this is my attempt here to try and give some kind of general terms to more advanced, less search term friendly use cases, which we'll get into right away here. But essentially the main theme behind all of these examples is that they're pretty advanced filter scenarios that are now a lot easier and made possible with LOD expressions. So our first example, just a nice example also to kind of get people used to just a refresher on why we built LODs to begin with, is an example that uses guided analysis. So the idea of revealing at a high level some information about the data at a lower level. So this example here is using Superstore for a business-to-business model where we have customers in a number of different industries, and those customers buy some product. And what our executive team wants to look at is to make sure that our salespeople aren't discounting too heavily. So we have the total number of units that are sold to each industry, as well as the free number of units that they've been given. So the discount rate is just free units per number of total units sold. And so when we are, as defined by this parameter here as well, our senior management considers a discount rate above 6% to be very concerning. So you can see here that summarized at an industry level, the discount rate is well below that threshold for every industry except for agriculture, but we probably don't care because in absolute terms, it's so few number of items that you can almost disregard that. The problem, though, when you aggregate data to this high level, like a discount ratio, is that you lose the detail about, is there some sneaky customer in there who's getting a really high discount rate? And so that's what these orange circles tell you is the number of customers within that industry that are receiving a discount rate above 6%. So here you can see that in transportation, there's actually 3 customers who are receiving a discount rate above 6%. And so that now takes you to the detail view that shows you who those 3 customers actually are. And this is fake data, by the way, so if you see people from GM, don't be like, what are you doing? How did you guys get that discount rate? This is Superstore. All right. And then you can go back again and drill into technology to see who's the one guy. Same thing goes for Dell. They're probably here. Don't ask them how they did this. It's not Tableau's data. All right? So that's kind of the idea here. And so, seem useful? Yeah? All right. So how we do this is we basically need to aggregate the discount rate by customer, but customer's not in our view. We only have industry in our view. So we would use a level of detail expression to look at that. Here it is. I'll just show you the expression. So to aggregate customers, or to aggregate the discount rate by customers. So that's what this fixed customer name does, is it will calculate free units divided by total units per customer. And if that exceeds the discount threshold, then return who those customers actually are. And so to build our actual viz, what we do here is it's actually just a dual axis chart. Something like that. And I'll make this a circle. So that's what gives us that little, the dot, basically, to indicate whether the customers are above or below the discount threshold. And then we can actually just drop that in our view here. And let me get rid of, let's move this up here. And we don't actually want that on color. I'll just stick it on detail. So you can see that there's a number of different customers here. And so then to actually get to see the number of customers, we can just use a little table calc trick here where we multiply an index function by that and then compute it using that value. And that'll just split it out. Maybe I'll rescale this with a different value. And so, well, maybe not that much. But anyway, hopefully you get the idea of how you can do that. So just a neat little visual trick along with the LOD expression. Sound good? Also, just to let you know, I see people taking pictures, and I often see people taking notes. This is going to be available up on the website. We're hoping to get it up on the website next week, so both the recording of the session as well as the workbook, so you can actually go through and you'll have all of these examples by next week. So sit back and enjoy. Okay, so our next example is looking at proportional brushing. So here we've got a map showing sales by country. We've got a line showing our sales trends across time. But now what if I want to see Brazil's sales versus all of Latin America's sales? Well, I can now do that. If I click on Brazil here, what that does now is the line chart is showing you sales in Brazil, is the green line across time, and then the black line shows you the total sales in Latin America across time. So we can actually see what that is relative to the whole. And then the percent of total is telling us by month what percent of our Latin American sales came from Brazil. And this works if I click multiple countries, so if I select Mexico as well, that now updates to show Mexico and Brazil versus the total amount of sales. And then the lighter green value will show you the percent of total sales that's from countries that are not in the selection. So you can make that comparison of selection versus what's not selected. Useful? Yay, good. Okay, so there's really just one fact that you need to know to be able to do this type of thing here. And that's how the order of filters are applied relative to level of detail expressions. And so the majority of what you're going to see in this session is based off of this one slide. That's one of the great things about Tableau, is that you don't actually need to have a lot of knowledge to be able to do cool stuff with it. Personally, my memory makes a sieve look like it has a high retention rate, so I've kind of just grabbed onto this one thing and try to make it do a lot of awesome stuff. So the key point here is that fixed expressions are evaluated between context filters and dimension filters. So context filters and data source filters, they're basically the same thing now. They happen first, Fixed expressions then aggregate whatever data has been included in the context filter, and then dimension filters are applied after that. So fixed expressions don't respect dimension filters. It sounds like it's a bad thing, but it's a very good thing. It's what enables us to do this kind of proportional brushing scenario. So we start off here with our sales across time. And so the fixed expression that we're going to use, all this does is fix the sum of sales to the month level. And month here is just a custom date part. That's all. So it's the same as what you see in the visualization. And you'll notice that if I bring total sales by month into the view here, these two things are, they are exactly equal for now. So when we have no filters applied, they're equivalent. And so the distinction between relying on the visualization level of detail to define the aggregation versus relying on the LOD expression to define the aggregation only comes into play when you start applying different filters. So if I now filter to Latin America, you'll see that the total line did not change, and the sum of sales did. So it's now showing Latin American sales versus the entire world's sales, which is kind of, it's not what we want at all, actually. So what we want is to find total sales in Latin America and then filter to a specific country. So what do we have to do with this to make the black line show Latin American sales? I heard the answer, add it to context. Well done. So that's it. Just add this to context, and now you'll see that they're back to being identical because fixed LOD expressions do respect context filters. And so now, if I go down to a specific country like Brazil, now that's what's showing you that comparison. This is actually just the action filter exposed. So the same principle applies whether you're using a dashboard action or a quick filter action. And then to get the percent of total, it's just a very simple case of of dividing these two by each other. And that's it. So very simple to be able to implement this type of filtering scenario in your analysis going forward. All right, our next example here is looking at market basket analysis. So if you want to understand what products are commonly purchased on the same order, this is a type of scenario that you could use. So here, this is just showing you the number of items sold by product subcategory. But if I now click on paper, what that does is it now shows in the dark blue bar, shows you the number of items that were purchased on orders that also purchased paper. So 102 binders and binder accessories were bought with paper, and that represents 11% of total binder and binder accessory sales, or items sold, essentially. Exciting? Yeah! I'm very excited about this. I sent an email to a lot of people when I found out that this works. Oh, they're like, go away, stop spamming us. Okay, so I'm happy that you guys are happy. All right, so how we do this, you can see that this is actually, it's similar to proportional brushing in a sense, because the light blue bar is unaffected by the filter, while the dark blue bar is affected by the filter. So this is like it's like a super advanced case of proportional brushing. The difference here is what we're passing through the filter. So I can't just filter on product. That was the opposite of what I wanted to do. So if you just filter on product, you're going to end up with something really unexciting. So what we need to pass through in the filter is the order ID. That's the dimension that is being applied in the action. So to show you more specifically how we do this, Let me go to the next, this one here. So, whoops. If we start out with just number of items by subcategory. I think I hit save and I didn't mean to before. All right, so we have our number of items by subcategory. So same thing like what we did with proportional brushing. We need to get this number, but as a fixed expression, so that it's immune to the filter. And so what that looks like is just fixed to some subcategory, the sum of number of items. And you'll see that if we put this in the same view, let me replace that. These things are exactly equal. And I'll just hide that axis there. All right, so that's step one. And then step two is setting up the filter so that it applies on the order ID level rather than on the product level. And so if you're familiar with actions, if you want to pass a dimension through in an action filter, it actually needs to be in the visualization. So what I'm going to do is drop order ID on the marks card here. And what that does is it now basically creates a bunch of tiny little stacked marks. So the visualization still looks the same, but the trick is kind of, hidden behind this. And so then when you set up your action, you'll say in the filter action, you're going to pass through not all fields in the view, because that would just be like keep only, but you're just going to pass through the order ID. And so then, clicking on paper now displays paper, or now displays each category's total sale, or sales on orders that bought paper. And the reason this works is because this action on order ID is a regular dimension filter, and so it's not being applied to that light blue bar. And if you wanted to, because from a user experience perspective, if you don't want to have all of these tiny little marks, you can use an exclude LOD expression to say, Tableau, don't do that, exclude the order ID from the sum of the number of items. And then that will just aggregate by product subcategory. And if we turn off stacked marks, then we'll get back to the same visualization that we had before, but now with just one single bar. I wish my colleagues had the same response to email spam. Okay, next example. This was inspired by a brand new Tableau user who last week asked me, can you do this? And I had to tell him no because I didn't want to overwhelm him, but I can tell you guys, yes, actually, we can do this. So here what you're looking at is profit by country, sales across time, looks pretty normal. But what if I want to compare Sweden's profit to Australia's profit? Well, now, when I click on them, it breaks down the sales or the profit by month for each country. But if I haven't clicked on anything, it aggregates it across the entire world. And so by default, if you want to achieve that behavior, you need to put country on your line chart. And so you end up with this spaghetti mess, crazy view that has 300 lines. And so this is set to apply that behavior only if you've selected less than 20 countries, and that's parametrizable. So if I select like loads of countries, it will continue to just display the total for those selected countries because it's actually quite an unreasonable thing to have 100 things on color. And so yeah, that's parametrizable. If I set this to be 200, then it would actually break down by country. So just a way to make the information more useful. All right. Any idea how we do this? I see 2, yeah? Pardon me? Count distinct? Yes! Yes! Winner! I wish I had a prize to give you. All I've got is a half-drunk bottle of water, but I'll give you a high five after. Okay, so yeah, effectively what we need to do is figure out how many countries have been selected. So doing a count distinct of the countries. But if I just do count distinct of country, that will give me the count distinct of country by month. But what I want to know is the count distinct of countries that are in the filter of what's been ticked, essentially. So I don't want to group that by month. I want to look at that across the entire data source. And so if you wrap this in magical curly braces, then, ta-da, it gives you 150. So that's the total number of countries that have been, or 147. So that's the total number of countries that we have in the entire data set. And you'll notice that if I now just select a couple of these countries, it's still at 147 because, shout it out, you guys know. Because, sorry? Yes, exactly. You're fixing before a dimension filter. So I have to add this to context, and now it retrieves the number of countries that have actually been selected in that quick filter. And so then our condition, what that says basically is if the number of countries is less than the drill down threshold, so if 5, if 5 is less than 20, which it is, then return the country. Otherwise, this is null or a string value. You could call it total, whatever. It just needs to be one single value. And so when we put this on color, oh, I put it on the wrong thing. If we put this on color here, now it breaks it down, but when I pick too many of them, it aggregates it across the entire data set, the entire selection. Yay! All right, so our fourth example, fifth, I don't know, I'm losing track. We're looking at path analysis now. So this is some data from the OECD that looks at foreign aid sent to and from different countries. So this map shows you how much foreign aid the United States is sending to other countries. And so it sends the most to Afghanistan. That's surprising. And then if you look at Indonesia or something else, it will reverse the graph. And now it shows you all of the foreign aid that's going into Indonesia. And so you can see that Australia is giving the most, probably because it feels apologetic for all of the Australian tourists who go and drink excessively in Bali. Okay, so how do we actually filter by country here? This is what it looks like unfiltered. It's a crazy spaghetti mess that's raining down on Africa. So that is a song. So if we show a quick filter here and then go and actually filter this down to a single country, surprise, it does exactly what you told it to, and it filters down to that single country. This is like, why? Why can't you know what I want you to do? So this doesn't work, essentially. To create this type of map, the way that the data has to be structured is to have one record or two records for every path, essentially. So you have a record for the recipient and donor country, and then there's this edge ID that connects those two together by having a common ID field. So what I want to do is when I've clicked on the United States, for example, I want to also keep this record for the Seychelles because it has the same edge ID as one of the edges that's associated with the United States. So to be able to do that, I'll get rid of this one here. Let's go back to the US just to look at that connection with the Seychelles. Okay, and so we need to create a filter condition here that filters at a higher level of detail than the row level. And so the inner condition, what this does is it looks to see if the country is equal to what you've selected, then return a 1, otherwise return a 0. So in that example, in the underlying data, the row with the US would have a 1, and the row with the Seychelles would have a 0. And then you take the maximum of those 1s and 0s, and then group it by the edge ID. So that edge that connects the Seychelles and the US, the maximum of 0 and 1 is 1. And so that then allows us to keep all of the edges that are connected to the selected country. So if we put this on the filter shelf and say yes, now we can see what's connected to the United States. So something that might blow your mind a little bit is that, and remember I said in the beginning, some stuff's really hard to search on Google. This problem, this path analysis problem, is basically the exact same data problem as the market basket analysis case. Because in both of these examples, we don't want to filter at a row level, but we want to actually filter at a higher level of detail. And so that's why it's useful to just understand how this works and save yourself the time trying to search for that on the internet. In terms of performance, the second case, the path analysis, will perform a lot better than the market basket analysis. Because in the case of market basket analysis, we had to put order ID on the visualization, and so that dramatically increases the result set that's being returned from the database to Tableau. So if you are doing this on really large volumes of data, better to use the parameter and the fixed expression. It's not as cool as being able to click on the viz itself, but this is sort of the classic trade-off between performance and flexibility. Are you guys good to keep going? All right. It's a fire hose of information. All right. This next example here is looking at competitor benchmarking. So what the scatter plot shows is the sales for our company versus the year-over-year growth. So this is what our company, or you can tell this is vastly anonymized data. I really did something wrong in there. This company has more money than the GDP of some countries, but anyway, ignore that. So this shows you the sales of our company for this year versus our year-over-year growth. So we're massive, we dominate the industry, but our growth rate is not enormous when you compare it to some of these little guys here that make no money, but they're very fast growing. So what you might want to do then is compare the growth of your company relative to the growth of your competitors. And so unfiltered, the view on the right here shows you that our company grew 8.8% year over year in clothes, shoes, and jewelry relative to the total market growth. And the only thing that we didn't grow in more than the market grew is grocery. And so if I now want to compare that growth of my company, instead of comparing it to the total market growth, I want to compare it to the growth of my nearest competitor, I can now just click on Income Corporation. And so now it shows me that this is not a little bit less optimistic. So we only grew 6% more in books than Income Corporation grew in books. But they grew 46.5% more in clothes, shoes, and jewelry than we grew. So if this is my nearest competitor and my nearest threat, that's probably the area that you want to focus on increasing your total market value. Make sense? Okay, so how do we do this? So the way that the data is structured is that you have a column for competitor, and that includes the competitors, but it also includes our company. And then you have a column for product categories. And then the year-over-year growth is just the sales of this year, whatever. It's year-over-year growth. You guys know how to do that. Okay, so in general, it's very easy to compare two columns across the same row. It's not easy to compare two rows across the same column. And what we need to do here is essentially that, because we need to compare every competitor to us. But our year-over-year growth is not in a separate column, in the same row in a separate column as all of the competitors. It's kind of unioned to all of the other competitors. So that's what makes this problem difficult. So the first thing we need to do is basically just isolate out of all these bars our growth. Right, so that's what the first calculation does, is you'll see these numbers are exactly the same as these numbers here, and we've just given null values for all of the other competitors. And so what I want to do is basically transform this into the case where we are able to compare two columns across the same row. That's the whole point of these expressions here. So then the second thing we need to do is now take those values and copy them the whole way down across all of our competitors. So just to show you what that does, it's now just repeating our growth by product across all of our competitors. And so now that the data is in this format, now we are able to compare two columns across the same row. So it's now very easy to just be able to take the difference in year-on-year growth between those two, which is just that one minus that one. Yep. Oh, no. Where's the... What have I done wrong? I might have kicked something under the table. Sorry? It's still on. I indeed kicked something under the table. Thank you. Just need to remember what that was in case it happens again. Okay, so let me go back. Was it still on at this point? Okay, so the main point here is now by replicating those values across all of our competitors, we've now got two separate columns that are comparable across the same row. And this is a very trivial and easy thing to do with calculations. We just take that one minus that one to get the difference in year-over-year growth, which you can see is correctly calculating here. Yeah, question? Is it better doing it? It can only be done using it. This can't be done using table calculations because so table calculations are calculated on the result set in your view. And the way our filter happens, we click on Income Corporation, and we've now filtered out our company. So a table calculation would not be able to do this because our company's data disappears. So this is something that pre-level of detail expressions was the opposite of fun. You would have to do crazy data blending workarounds. So yeah. Okay, so now to look at now hopefully everyone understands the problem setup, how you kind of go about thinking about how to solve this. And then in terms of the actual calculations, what those look like is we're basically just saying here, if the competitor is our company, then give the year-over-year growth by competitor and by product. And if you're wondering, why are you using a fixed expression when you're just fixing it to things that are already in your view? It's because, wait for it, this was the second thing that got that my colleagues got spammed for when I discovered this, is everyone's least favorite error? Oh my God! Because fixed expressions return row-level results, you can just use them to make that error go away. All right, so that's what returns the value. And then the second calc that replicates it across all of the other competitors, what we do is then say, by product, take the minimum of this value here. And so the minimum, so by clothes, for example, the minimum of 29% and all of the null values that you get across all of the competitors is obviously 29%. And so that's what causes this replication to occur across all of the competitors. And then the last bit is just a subtraction of the two, so that bit's trivial. But again, the reason why this works is because fixed expressions are evaluated before filters are applied. So I can filter this down to Allied Biscuit, what a name. And then we can still retain the comparison to our company, even though our company has been filtered out of the view. So it's pretty simple, given that that could otherwise be a very hairy problem to solve. Yay! All right. The next one here is looking at, actually before we do the example, question for you guys. If you have a passport to any country in Asia, please stand up. Oh, okay. Stand up, come on, get involved. All right, cool, a lot of people traveled far, awesome. Just stay standing up. This is an interactive activity. Okay, if you have an American passport, please stand up. Whoa. And that's the next question. Only remain standing if you have both. We have one guy. Okay, so how do we do that kind of filter in Tableau? We can filter by nationality, and the more you pick, the more data you get. But what if I want to say, who are all the people that have this nationality, and this nationality, and this nationality, where the more you filter, the less data you get? Well, that's what this example looks at. So here we have sales by customers. I filtered this to 1 quarter. But now, what if I want to see who are the customers who bought in both of the selected quarters? So these are all my customers who bought in Q3 and Q4, whereas these are all my customers who bought in one of those. And so the more things I select, the more this data gets smaller and smaller. And I can see that there's now actually very few customers who have bought in the last 5 quarters. Any idea how we do this? Yeah, so count distinct. You need to be able to figure out how many quarters are actually selected in that quick filter. So this is a really similar example to the one where we conditionally break down a line by country. So how we actually do this, so we've got our customer, our sales by customer name. So if I do a, so if I do a count distinct, of quarters. And this is, again, it's just a custom date part at the quarter level. And I've wrapped this in curly braces. So that will find, if we turn on the labels here, that finds the total number of quarters, which is 16. But to find the number of quarters that have been selected, I have, oh, there it goes again, but I know how to fix it this time. All right, so how do I make this number turn into a magic 4? Add it to context. See, it's really easy. I told you don't need to know much. There we go. So now it's picking up the total number of quarters that have been captured in that quick filter selection. And so then if I want to compare that to the total number of quarters that each customer has purchased in, then I'm going to fix on the customer level the count distinct of quarters. And the reason that, order date, there we go. The reason I'm using a fixed expression rather than just doing a count distinct and relying on the fact that customers in the view is because, yes, so that we can avoid that horrible error. Exactly, because it's easy to compare then these two things at a row level. And so now I can see that the only guy in this view who bought 4 times is Shahid. So now it's just a simple case of doing a Boolean comparison to see are these things equal to each other. And boom, we don't really need that anymore. I mean, you could just filter by this. Depends what you want to do. We can do something like this to compare the top ones in and out of both, however you like. So you can change the way the view's set up. We would just keep only the true values if we only wanted to see the ones that actually bought in all 4, rather than comparing them to the ones that bought in some of the selection. Cool? Yay! By the way, is Keith Helfrich in the room? That's you. So this was actually, you filed a support case that Noah Salvatera, yeah, that was your support case that gave me this idea. So all of our ideas come from you guys. So thanks for that. Awesome. I'm so happy you're in the front row as well. You didn't shy away to the back like everyone else. Okay. I've saved possibly the most exciting example for last. So if I want to drill down from states to cities, currently what you have to do is have 2 separate worksheets, and one worksheet filters the other worksheet. But wouldn't it be so awesome if you could just do this? Oh my God, let's do that again because that was so much fun. But now let's do it for the whole East Coast. Come on, tooltip. And so it works for multiple states as well. Yay! Yay! There might be developers in the room, so the louder you clap, the more likely they are to build these things. All right, so who has an idea of how this works? Magic. No, not magic. I told you, it's kind of the same, it's the same technique over and over to do a million cool things. It's distinct counts, yay, and context filters. So basically, this is a dual-axis chart between a map at the state level and a map at the city level. And so what we do here is similar to the other examples. We just take a count distinct by state, and if that's less than 49 in this case, you can set this It's parametrizable, so you can decide at what point you want to drill down or not drill down. Then return the city. And then it's null if the number of states selected is higher than 49, as in we have all the states in the view. So then we've assigned a geographic role of city to this. And so on the level of detail here, instead of having our actual city field, we'll put this city field that is sometimes a city, and sometimes it's null. And then the same is true for the state. We say if the number of states is greater or equal to the parameter that you've input, then give the state value, and otherwise this is also null. And that has a geographic role of state. And so then on our first marks card, that's what we display. And it keeps that because at the moment I have all the data in the view. So now if we layer those on top of each other, and if I come in here and do keep only, it doesn't do it. Why? Yeah, you only need to know one thing. We add it to context, and then it does do the drill down. And to reset it, you can actually expose a keep only filter as a quick filter. And so then you just go back to all to be able to reset it. So this is a really simple trick to be able to do that. Yay. Okay, the last example. This is more for people who are administrating content to a very large number of users across an organization that has a hierarchical structure, and you want to manage the minimum amount of workbooks as possible. So who in the room, raise your hand if you're more on the content management, server management side of things. Cool, this is for you. So here I have a blank dashboard. Oh no, but basically in this data set I have market level data, country level data, state level data, city level data. And so what I want is when the CEO logs in, he sees data aggregated to a regional level. When the vice president of a region logs in, he sees data displayed by country. And when a country manager logs in, he sees data displayed by state. And when a state manager logs in, why am I saying he? She sees data. No, but the CEO is a she. Forget about that. She sees data at a city level. So this is now kind of possible. So in our server, the CEO his username is the Big Kahuna. So if we look at what does the Big Kahuna see? She sees. She sees now total profit and sales across the entire company, and then broken down by region. This would be a really boring chart for someone who's a state-level manager, because they would just see one bar for just their sales. So that's why we want to be able to dynamically swap out what visualization is displayed here. So if the vice president of Africa logs in, now they don't even see that bar chart, because again, it would be one bar, which is equivalent to this summary value here. So instead, they're presented with a map that's displayed at the country level. And likewise, if the director of France logs in, they're displayed a map at the state level. And then if, I'm going to put the Alberta manager, because that's my hometown. Hi, Mom. Now we see this at the city level. There's my hometown. It is very far north and very cold. And so now you don't need to, today, the way that you need to do that is by having 4 separate workbooks, essentially. That is still the advisable solution, by the way, because this is really messy and it can get slow. So this is just if you have a really simple workbook and not a lot of data, you could think about using this method. But if you have really complex workbooks with lots of worksheets and large volumes of data just don't even go near this. Because behind the scenes, what's happening is magic. Not magic. It's the same. This is just like the prior example on steroids. There's basically a whole lot of count distincts going on to be able to figure out the level of detail of the data that user has access to. I'm not going to go into this one because you can download it and reverse engineer it if you want to do it. But it was just to show you the level of, the kinds of things that you can use LOD expressions for. All right, so in conclusion, we started off with a very bad pun, and we're going to end off with a very cheesy viz. I told you at the beginning that there's really only one key fact that this entire session is based on. So that's really all that you need to remember. That's what's great about Tableau is you don't need to have a lot of knowledge. You just need to have a couple of bits of information about how the product works, and then you can just use your imagination to do whatever you want. So as you're going through the conference, you're probably going to have a lot of information thrown at you. Don't feel overwhelmed. Just remember a couple of key things, and you'll be amazed when you go back to work next week at how much you'll be able to do with those couple of facts. So that's really all I had prepared for in terms of content. So we'll take the last 10 minutes for any questions that you have. Yeah?
You put the curly braces around a calculation. Is that doing a fix?
Yeah. So the question was, when you put the curly braces around a calculation without specifying a keyword, that is doing a fixed. So that's why any time I used curly braces, they ignored regular dimension filters because they behave the same way as fixed expressions. Good question, thanks. Yeah. Sorry, could we actually get a mic over here? So just down there, other side, by the speaker. Yeah. Affected. That is a really hard thing to put a number on. You sort of have to test it. So that's why I said at the end, with that last example, use this with extreme caution because it will hurt your workbook performance to an extent. But you'll only start noticing that if you have absolutely massive volumes of data. The majority of people are often working off of data in Excel, and you'll never notice that as a performance problem if you're working on sort of smaller volumes. You kind of just have to test these things. Any other questions? Keith?
In the cohort analysis, you had to bring the order ID into the level of detail.
Yes.
And then you excluded it back out for fall.
Or the market basket analysis, you mean? So let me just, so this one here, I did not exclude it. It's an action, oh, sorry. Oh, yeah. Sorry, in this expression here. So the reason that I did that is so that I could retain the sum of, retain this value of 102. Because if I didn't have that, if I just had the sum of the number of items, that sum is then grouped by product category and by order ID. So if I turn stacked marks back on, you can never see that this is equal to 102. It's just 102 stacked marks on top of each other. Yeah, so the exclude is still, it's a level of detail expression. It's kind of a workaround. So we need to have order ID in the view to be able to filter on it. That then basically breaks our sum of sales. So the exclude is to bring it back up to the total per subcategory. Good question, thanks. Yep. Yep, so the question was, can you select multiple on this? You can. So if hold on, let me see. So if I pick office furnishings and computer peripherals, so what that now does is it filters on all of the order IDs that had office furnishings or computer peripherals. So it's, in that sense, it's not, but it's just the ability to pass through the order ID to do the market basket analysis. It's just a different example, I think, but in that sense, it does OR the values together. Yeah, another question? Yeah. Oh, how do you prep your data to have the edge ID? So how I did this, so yeah, the file that I originally downloaded had a origin and destination. So I first added a record ID and then did a pivot. And so by adding a record ID, that means that the origin and destination end up having the same, when you pivot it, they keep the same value, and you use that as your edge ID. They were columns in the, yeah, so for the path analysis case, probably you won't have your data natively in that format. You need to pivot it so that you have, instead of having an origin and destination column, you have a single column for country, and then an identifier that says, is it the origin or is it the destination? And then another column that pairs together, things that are on the common path. Yeah.
So you see this as being really powerful when you're looking at average versus total?
Yeah.
So have you done before where you basically take different averages by different totals? So you're looking at the total of your superstore, right?
Yep.
Versus the total of the business unit. Because like different managers are going to
A different thing.
things, right? So like, have you done that?
Yeah, so I actually did that last week. I was at a large company that sells pizza that you've probably consumed in your life. They have a number of franchisees, and then their franchisees have a number of stores, and those stores are in different locations. So they have in London, which is where we're based, they have a number of franchisees in London that have different stores. And so the franchisees want to be able to compare how their store is doing relative to, first of all, the total average sales across all franchisees in the country. Then they wanted to be able to compare it to the total sales or the average sales across stores in their region as well. And so, yeah, we actually did exactly that. We used level of detail expressions to be able to do that. And what was also awesome about it is that the security was set up so that when a franchisee logs in, they only see their stores, but the average still includes the data from other franchisees who have been filtered out via the row-level security. So it's another case of something that you probably would have struggled to do before 9.1 or 9.0. There were no parameters. I can show you after if you want. Any other questions? Yeah. Well, so they're different in the interface, but they're essentially, from a query perspective, they're basically the same. There's a talk, Scott Sherman and Ronal Sridhar are doing a talk on the query pipeline. So go to that if you want to know more details. Yeah?
So I have some sheets that I can use data engineering calculated with fixed line and possibilities.
Yeah. I would definitely recommend doing so. It's a lot easier to maintain than blending, because with blending you can accidentally turn off a link and you don't know what happened, whereas here you're explicitly defining your aggregation. So yeah, it's a lot easier to manage in that way. It's hard to say, because blending, it depends on the cardinality of the blend field. So if you're blending on something like product subcategory that has 10 items, blending is going to be pretty fast. If you're blending on order ID, that's another story. Yeah. So again, you kind of have to test it. All right, do we have time for one more question? All right, yep. Yeah, so the question was, other than fixed, are there any other expressions that, do you mean in the order of filters? No, just fixed. So include and exclude happen after dimension filters. So if you need to mess around with filters, you basically always have to use fixed expressions. All right, I guess that takes us to the end. Thanks very much for coming, and see you at the party tonight!